All right, here we are, finding inverse functions. So one of the things you need to know right away is when we think about inverses in math, think about opposite, okay? When you think about inverses in math, think about switch the variables, okay? So really important to think about those two things. Think opposite, think switch the variables. So a little notation first. So if you think about the notation on this, if f of x is a function, the inverse notation uses a little -1 up there. So if y is a function, its inverse notation is that little -1 up there. So that's how you deal with the notation. So this is the function, this is the inverse. Okay, so when I say we're going to switch back to the inverse notation, when I make reference that, that's where I'm getting that information. As far as points on inverses, if f of x has the point, and I'm just arbitrarily picking a, b, could be any number, then the inverse which would be like that, has the point b comma a. So again, look at what we did. Switch the variables, switch the points. That's kind of the theme for what we're doing on this, is we're switching the variables or switching the points. So when we are finding an inverse, here's the directions. Directions to find inverse. Okay, hopefully you've kind of gathered the first thing you're going to do. Hopefully you've kind of gathered what the idea is. You're going to switch the x and y. Okay, every y make an x, every x make a y. So switch the x and y. The second thing, solve for y. So take that new equation, solve it for y using algebra. And the third thing you're going to do is replace y with the inverse notation. Okay, so you're going to use the inverse notation to finish it off. So let me show you an example. Find the inverse of the following function. Okay, think of one thing to think about. Y and f of x, they're really the same thing. They're the same thing. So just know y and f of x are the same thing. So if I wanted to, so we'll get back to that function notation, but it might be easier. You know, we start out, we have this equation. Step 1 says what we're going to do is we're going to switch the x and y. And that's just it. You just switch them. Step 2 says go through using algebra and solve for y. So if I don't skip any steps, the first step I would do on this is I would subtract 9 from both sides. Next thing I would do to get rid of the 1/2 is I'd multiply by 2. And that's it. And now I'm just going to use the inverse notation So if I rewrote this, that would be it. My answer, because it started out as a function notation, I'm just going to switch it and make it inverse notation. And I'm going to write 2x minus 9. Okay. You could write it 2x minus 18. I don't think Delta Math will punish will. I don't think they're not sending to write it in a special form, so I think they'll accept either one of those two answers. So we switched the x and y, solved for y, wrote it in inverse notation. Okay, so let's do another one. First thing we got is we got this equation, 4 over 9x. We're going to switch the x and y. We're going to make the y x, and we'll make the x y. There's a couple of different things we can do on this. Okay, so I'm going to do some algebra on this. If I multiply both sides, so let me rewrite it over here. X equals 4 over 9y. If I multiply this side by 9y, then I got to multiply this side by 9y. And that just gets the y's out of the bottom. So I have 9y times x. Actually, let me back up. I really don't need to do that. I don't need to move the 9. I just need to move the y. So let me redo that. X equals 4 over 9y. If I multiply this side by y, I got to multiply this side by y. I would now have y times x equals 4 over 9. Now if I divide by x, I'd have y is equal to 4 over 9x. Some of you might have done that in one step. It's just fine. So now our answer then is the inverse is equal to 4 over 9x, or you could write it as the inverse is equal to 4 over 9x. But we've now made it into the inverse, and the final answer is either this one or this one. Either one of those is a fine answer. Okay? So we're switching the x and y, solving for y, using the inverse notation. It's the same steps every single time. So if we take this one's a little bit more challenging. They're getting a little bit more difficult, but let's think about this one. So if I switch the x and y, or something like this. Think about this. Another way of thinking about this particular one is this is like x is divided by 1. And if you have two fractions like this, you can actually just rewrite them as 1 over x is equal to y minus 4 over 10. We could go through the algebra to solve it, but in truth, when we have two fractions that are equal to each other, we can just flip them. The kind of thing like this. If 1/2 is equal to 4/8, 2 over 1 is equal to 8 over 4. I mean, those are the same thing. So we can flip fractions if they're equal to each other, if it's just a fraction. So I'm going to use that step. If you have trouble with that, you can go back to what we did on the last problem, but I think this is going to be easier for this problem. So then what I'm going to do is I'm going to multiply by 10. So I have 1 over x times 10 is equal to y minus 4. I'm going to go up here, and I'm going to add 4. So I have 1 over x times 10 plus 4 is equal to y. Well, that is now the inverse. 1 over x times 10 plus 4. Or we can use the inverse notation, which is probably what Delta Math would want you to do. I wouldn't care necessarily if it was a test, but that would be my answer. All right, last one is a little bit more challenging. Okay, so we'll do our best to do this one. So first thing we're going to do is switch the x and the y. Okay. All right, so this one, arguably a little more challenging to solve that for y. So we got to figure out how to do that. So here's what I'm going to do. I'm going to multiply both sides by 2y plus 1. So I have this, I have x equals 4y. I'm actually going to, let me back up. Let me do the same thing I did on the last one. Got these two fractions, right? This one's divided by 1. So I'm going to have 1 over x is equal to 2y plus 1 over 4y. This one I would say is a lot more, it's a lot more challenging, honestly. So you're going to have to bear with me on this one. So if I were going to do this one, one thing I could think about with this is I have 1 over x is equal to 2y over 4y plus 1 over 4y, because I can split that up into two different fractions. Once I've done that, I get to reduce the y's over here and make this 2 over 4. Could write it as 1/2. So I have that. If I subtract 2 over 4, if you want to write that as 1/2, that's fine. I'd have that. So right now I have 1 over x minus 1/2 equals 1 over 4y. So I need to get that y out of the denominator. So I'm going to multiply both sides by y. Multiply that side by y, multiply that side by y. I'm not going to do any distributive, but what that's going to do is going to get that rid of it for me. So y 1 over x minus 1/2 equals 1/4. Next thing I'm going to do is I'm going to divide by all that stuff in parentheses. And I know it looks messy, but that is my answer. There's simplification you for sure can do. I believe that Delta Math will accept that answer. So in the end, my answer would be the inverse is equal to 1 over 4 divided by 1 over x minus 1/2. Go back on this one. Look at the steps, the algebra steps that I did to get from one line to the next. And if you have questions, come back on the Zoom call or wherever we are and ask me about it. But you're going to have to do a problem like that. So that's a little bit more challenging. All right. If you were asked to graph the inverse, here's a function you have to graph the inverse. And it says you got to plot at least 5 points. Remember, if the function has the point AB, then the inverse has the point BA. So you just switch the B's and the A's. You switch the coordinates. So if we have to just plot 5 points, I might take this point right here. That's the point right there. That's the point 0, 4. So if I plot the point 4, 0, I'd get that. If I think about that, this is the point 0, 4. So I'm going to plot the point 4. So I'm going to plot the point 4, 0. So I'm going to do that. I'm going to find a few more points like that, right? So if if I take this point right here, right there, that looks like the point 1, negative 9, or sorry, negative 9, 1. If I plot the point 1, negative 9, I'd be down here, down something like that. If I plot this point right here, that point right there might be the point. So that point is negative 8, 2. So if I plot the point 2, negative 8, I'd be right there. If this point right here is the point negative 8, 0, then I just need to plot the point 0, negative 8. And if I plot this point right here, that's the point, that point right there is 0, negative 2. Then I'm going to plot the point negative 2, 0, negative 2, 0. And when you do that on delta math, I've plotted 5 points. What I'm going to get is I'm going to get a graph that looks like that. Okay, so it should take on the same shape. It just should be flipped. Hopefully this helps you. If you have questions, remember to ask.